when you're finding the error term for trigonometric functions such as fz is equals to cos z or fz is equals to sine z, we do not consider the values of z. Remember, we choose z. All right. Now, cos z it has a boundaries of values that you can, cos z is between -1 and 1, and sine z is between -1 and 1. Now, we do not consider the value of z that will maximize the error, rather the value of cos z and sine z. All right. So we look at that function at z. All right. Now we know that cos z is less than or equal to 1. The absolute value of cos z, all right, is less than or equal to 1. And the same thing, the absolute value of sine z is less than or equal to 1. So if we want to find the maximum error, remember the error term is used to approximate, all right, approximate the error. So if we want to find the maximum error, then we use 1 for both of these functions. Okay, and I'll explain that when I'll be solving through this question. All right, so example 3, find the third degree Taylor polynomial for sine x about pi over 4. So what I'm going to do is to start by finding the derivatives and the values of those derivatives. So a, f of x is equals to sine x. So the value of sine x at x is equals to pi over 4, that will be equal to sine pi over 4, which will be equal to, we know that's 1 over root 2. All right. And then f dash x will be equal to cos x. So the value of the first derivative of this function at x is equals to pi over 4 will be equal to cos pi over 4, which will just be equal to 1 over root 2. The second derivative of this function will be negative sine x, and at x is equals to pi over 4, that will be negative sine pi over 4, which will be equal to negative 1 over root 2. So let's move on to the third derivative. It will be negative cos x. So the value of the third derivative at x is equals to pi over 4 will be negative cos pi over 4, which will be equal to negative 1 over root 2. Do we need to keep on going, or let's check? They just want third degree Taylor polynomial, so we can stop there. And then we can go ahead and plug this into the Taylor series formula, this one here. So that will be, we can say sine x centered at pi over 4 will be equal to, so this is centered at pi over 4. That will be equal to f pi over 4 plus x minus pi over 4 f dash pi over 4. Remember, I'm using this formula here, right? So just plugging in these guys and seeing what we end up with. All right, let's carry on. Plus x minus pi over 4 squared Plus, not sure if this will fit here. X minus pi over 4 cubed F3 pi over 4 over 3 factorial. All right, managed to fit it. So, which means that sine x centered at pi over 4 will be equal to 1 over root 2. We have calculated that above there. Plus x minus pi over 4 squared over 2 root 2. Oh, 2 root 2? Not really. Let me check again. I think I'm skipping to the next one. So this will be 1 over root 2 plus x minus pi over 4 over root 2. Had skipped one term, which will be, that's a negative. All right, just checking my signs are correct. So plus, plus, minus, minus. All right, so that will be minus x minus pi over 4 squared over 2 root 2, because f second derivative of the function, the value of the second derivative at pi over 4 is equals to negative 1 over root 2. Yes, that one there. All right, minus x minus pi over 4 cubed over 3 factorial 6, so 6 root 2. All right, just checking that everything is correct. Good. We can carry on. So this will be equal to, this is it. All right, this is it. And that is the third degree Taylor polynomial of sine x about pi over 4. Yep, you can't simplify it further than that. We'll leave it as it is. Now, B estimate, so we are done with that. B estimate sine pi over 5. So for B, we'll just plug in pi over 5. Remember, this is sine x, all right? So sine pi over 5, we're just going to plug in pi over 5 in place of x. So that will be 1 over root 2 plus pi over 5 minus pi over 4 over root 2 minus pi over 5 minus pi over 4 squared over 2 root 2 minus pi over 5 minus pi over 4 cubed over 6 root 2. And that will give us, if you plug in the calculator, that will be 0.5878. All right. Let me just write this properly. Okay. So we are done with B. Now, see, use the error term to show your approximation is accurate to 3 decimal places. So what you're going to do is just write the error term down. Now remember, like I said previously, the error term is in your formula booklet, all right? You don't have to cram this error term. You can just use it. Here it is. I use it in a different form. You know, the letters are mixed up, but it's just the same thing. So just to be consistent, I'll use what I've used previously. So the error term is given by, and this is from my previous videos, that will be the n+1 derivative of f at z, x minus c, to power n+1 over n+1 factorial. All right. Like I said, this is exactly the same thing as that, only that in place of c I have z, and but it's the same thing. Now, in this case, c is equals to pi over 4, n is equals to 3, and x is equals to pi over 5. So in this case, so I'm just writing this down because this is the information that you're going to plug into this formula for error term. Now we are using the third degree polynomial, so that means n is 3. That's where that's coming from. So R3 at pi over 5, right? Because remember we used pi over 5 in our approximation, all right? So that's where that's coming from. So that will be equal to the absolute value of now the n+1 derivative. I'll talk about that in a minute. Oops, what happened? So the n+1 derivative, let's write that there. Or actually I can write that will be the fourth derivative at z, because n+1 is 4. All right, 3 plus 1 is 4 at z, and then this will be x is pi over 5 minus pi over 4 over pi over 5 minus pi over 4 n+1, that will be 4 over 4 factorial. All right. So basically, use this information to plug in there. So the fourth derivative, is we can actually find it. If we go up, we stopped at the third derivative. So the fourth derivative will be equal to sine x. All right. So the fourth derivative is equals to sine x. But we said that, and we know that, absolute value of, so I'll just write this statement down. Since the absolute value of, the fourth derivative of this function at z will be equal to sine z. All right. But we know that absolute value of sine z is less than or equal to 1. So we shall just take the maximum value of sine z, which is 1. All right. So since and this should give us the maximum error. This should give us Okay, so what does that mean? So here, what you're going to end up with is R3 pi over 5, and basically what you're going to do is we are going to, in place of this bit, we'll plug in 1. So what we'll end up with is um, pi over 5 minus pi over 4 2 power 4 over 4 factorial, which will be equal to 0.1234 Now remember, the question was, this will be the error, okay, when we use the third degree polynomial to estimate the value of sine pi over 5 centered at pi over 5. Now the question was, use the error term to show that your approximation is accurate to 3 decimal places. It makes sense, because if the error, all right, if the utmost error is that when you use the third degree polynomial, then it's accurate to 3 decimal places, because our cutoff point will be there. So it will definitely be accurate, all right? Hence our approximation is accurate to at least 3 decimal places. So we can say